get started.
Higher percentage of prices.
Thank you very much for coming to the Climate Change and Superstorms panel. I am Desiree Schell. I'm the host of Canadian science radio show Skeptically Speaking. And maybe we'll have the panelists introduce themselves, just starting from the end.
Okay, my name is Laden. I blog at scienceblogs.com, Greg Laden's blog, and I'm a biological anthropologist, and that has involved having interest in paleoclimate. I've studied human evolution, and I've studied paleoclimate over the last few million years, and as of the last few years, especially as a science communicator, I've been involved in communicating science mainly about climate change, and actually I've recently changed my default setting for which category my posts go to, from biology to physical science, because I blog much less now about evolution, and I blog almost daily about climate change activism, and climate change science.
Good afternoon. My name is Desiree Hamilton. I am the Science Policy Director at Fresh Energy in St. Paul, and we are a private nonprofit. We're at fresh-energy.org. I'm a climatologist by training. We were formed by a group of Minnesotans who were deeply concerned that in our small state of Minnesota, we spend $25 billion a year on energy, most of it going out of the state of Minnesota to buy dirty and dangerous sources of energy. And we thought that there was a better way forward. And so we work and help citizens help advance and advocate for clean energy and climate policies.
I'm Shawn Otto. I'm a co-founder of sciencedebate.org, which is the national nonprofit that gets the candidates for president to debate the big science questions facing the country every 4 years. I'm also author of Only Twice, Fighting the Assault on Science in America, and I speak about climate change and climate politics and climate science around the country and in other places.
All right, so what we'll do is we're going to talk a bit, and we'll save questions until the end. But I'd like to talk about something that just happened recently. President Obama actually came out and said some things about climate change. And Greg has actually called it the Gettysburg Address of climate change. So can we just talk about what happened there?
Well, yeah, he talked about several policy issues, and I don't think I should talk about those now. They included things he needs to do because he's legally required, and things that he doesn't need to do but should do, and so on. We can talk about those, but what he did in this address, which I think is very important, is he initially, in several ways, much longer than the Gettysburg Address, he explicitly said that the national discussion about the reality of climate change really just has to end because it is causing more trouble than it's worth. He talked about how we have to, this is not a meeting, we don't have time, he said, for a meeting of the Flat Earth Society. We have to take action now. And he also said, and I thought this is actually, to me, a very interesting thing, because it blurred the line that some people might claim to exist between politics and policy, or presidential behavior and party behavior, when he said, in one part of his speech, Republicans are responsible for stopping action on climate change, even though in the past they were responsible for most of our positive environmental legislation. And he also said, you should not vote for anybody ever again who doesn't have a very clear understanding of climate change, which was the Shawn Otto stuff here, and knows the science and is willing to accept and understand it and do things about it. And we put those two statements from his address together in one paragraph. He's saying, making a very strong political message and a very strong policy message at the same time. And I think that's the Gettysburg Address, because what it means is, meaning simply the high watermark of a certain philosophy, a shift in philosophy in the country, because we have to understand that this is no longer an issue where we can give credibility to two positions. We can no longer say, well, there's two political parties and they're saying something different, therefore those positions are real. Because they're not both real. One of them is real and one of them simply isn't. And I think that's why it's kind of a turning point in our public policy and a conversation about our public policy.
And so what I'd like to ask the other two panelists are, is that actually going to create anything tangible, or are those just words?
Yes, he didn't just give a speech last week. What President Obama did was to point out what most Americans do not know. 57% of Americans think that we already have limits on carbon pollution from power plants and other industries. We have no limits on carbon pollution. And the President pointed out that it is not a morally responsible thing to do for our kids and future generations to allow coal-fired power plants to continue emitting as much carbon as they like without limits. He said the non-existence of limits is not morally defensible, it's not right, it's not fair, and it needs to stop. And so on the same day, he issued a directive to the Environmental Protection Agency, which was formed in 1970. Some of the people will remember 43 years ago when the very first thing that happened after that first Earth Day on April 22nd, 1970, was that a Republican president, Richard Nixon, signed into law the Clean Air Act. And so what President Obama is going to do is not skirt Congress. Many people have pointed out that Congress seems unable to do anything, much less pass climate policy. But a previous Congress, in a strong bipartisan fashion, in 1970 passed the Clean Air Act. And here in Minnesota, I'm proud that 100% of our congressional delegation, Republican and Democrat, voted for that. And it was because it was about protecting human health and welfare. And under the Clean Air Act, as certified in 2007 by the very conservative U.S. Supreme Court, it is the obligation, it is a requirement of the Environmental Protection Agency to, for the first time, set limits on carbon pollution from the #1 source of climate change in America and in Minnesota, which is coal-burning power plants. And so the president laid out a directive and a schedule to the Environmental Protection Agency to make that happen. So this is a very tangible, very concrete result.
The other thing that he was trying to do is to use the power of politics and public opinion to put pressure on elected representatives. One of the big problems that's happened since he was first elected in 2008 and made some kind of climate legislation a priority, as he outlined in his answers to Science Debate 2008, is that the climate denial movement, particularly funded by the Koch brothers and Koch Industries, has really grown up in a lot of ways. In 2010, when that legislation was before Congress, the Koch-funded Americans for Prosperity, their leader Tim Phillips, really got organized and started funding, traveling around the country with a hot air balloon saying carbon taxes are going to increase your taxes, it's going to ruin businesses, it's going to cost jobs. And traveled all around the country, and particularly in the districts where Republican members of the House, there were 8 of them that had voted for this initial bill before it went to the Senate, and encouraged people to call their senators in those similar related districts and any other swing senators and get them to vote against it. So putting a lot of pressure through the voters again, which is what President Obama is now trying to do on those senators. Then Americans for Prosperity targeted the 8 Republicans that had voted for the climate bill with massive investments in their districts and knocked them out in primary battles. So all 8 of them. So all those Republicans lost their jobs in Congress, and that put the fear of God in all the survivors. And that is all that they had to do to change Congress and to convince senators to not vote for this bill. And with the investment of about $500 million, which at the time was an enormous amount of money over 9 months, roughly $1,800 per member of Congress per day, they were able to stop that bill from happening, and even though public opinion supported it. So there's a very concerted effort still underway to fund through Americans for Prosperity and a lot of aligned groups, climate denial, and to get Americans in particular confused about climate change and whether or not it's real. This is happening to a lesser degree in England and Australia and a little bit in Canada, but everywhere else that I've been in the world, people are mystified about how you could possibly be confused about something where the science is so clear, and I'm constantly asked about that.
Well, let's talk a bit about that. How do we know that climate change is real? Can we talk about some of the science and some of the, I guess, the weather changes and the events that are happening that show us that climate change is real?
Okay, well, I'll make this brief, but I have to go back about several tens of millions of years. If you go back to couple hundred million years ago, up to many tens of millions of years ago, there were several periods of time that lasted a bit under 10 million years each, in which the world's oceans changed. Some of the world's oceans changed their biochemistry and their ecology, and became carbon sinks. They took things that were life and turned them into yak that fell to the bottom of the sea or into continental shelves. Same time, at a more steady pace on land, large marshy wet areas. If you've been up to the morass in Minnesota, this is a good example of a place that will be someday it will be a coal mine in like 10 million years from now. So over this period of time, carbon dioxide from the atmosphere, at very high levels, was reduced over steadily in fits and starts over time, and eventually it got down to into amounts low enough that the amount of influence that the carbon dioxide had on the atmosphere was relatively minimal. It's an important greenhouse gas, but other things that caused glaciers to form and melt and so on became more important. Orbital geometry, for example, became more important in the flow of water in the seas and so on. Before that, things were just very warm because the carbon dioxide was so common that other factors were less important. And then that became less important. So from sometime in the 19th century to the present, we have burned the oil off, what was originally in the bottom of the sea, and we are burning off the coal to the extent that we have caused an increase in carbon dioxide in the atmosphere that has never ever been seen since life evolved in multicellular form on this planet. The rate of carbon being and other greenhouse gases as well. So today, on this day, it was yesterday, the Earth was as far from the sun as it gets in our current orbital system. That should be associated with an increased period of cooling. And according to the orbital geometry model of ice ages, we should be heading into an ice age over the next several decades. But the amount of carbon dioxide in the last century and a half has gone from way under 300 parts per million to just now 400 parts per million and rising. So it has turned that system off, and we're no longer going to have those influences on climate anymore. We have eliminated the possibility of the future ice age pretty much. Probably, we're not sure, but when we hit 500 or 600, we will absolutely certainly have turned that off. Okay. As a result of this, several things. I'll just mention one thing that has resulted from this as a direct result. That is, we've melted the Arctic more so than earlier. In fact, I got an email at 12:08 a.m. from a colleague, Shawn might have got a CC on this, that the Arctic ice last year melted dramatically in the beginning of the melt season and stayed lower than it's ever been that we've measured in 30 years or so. And it was a dramatic, remarkable event. This year, it's only been just touching the 98th percentile of previous 20 years mark, which is low, but it's not horrible and catastrophic and scary looking, until a few days ago, when it started to melt dramatically, and now that line is dropping, and it's possible that we're going to have less ice at the end of this melt season than ever. And we weren't really expecting that. That's kind of a surprise. Because the Earth, the heat that comes from the sun focuses on the equatorial regions and spreads to the poles, and that's what climate is about, is the distribution of heat from the equatorial regions to the poles, and everything else stems from that. And as part of that, there's a gradient of temperature, which causes a gradient in air pressure, which causes bands of weather to be different. So deserts are in one band, and rainforests are in one band, etc. And jet streams divide those bands up. But when you decrease the gradient by warming up the Arctic, the jet streams do something different. Instead of being nice kind of straight necklaces around the planet, they become wavy necklaces. Okay? So the desert Southwest has recently, California has recently been in an upward moving wave, a ridge, which has caused extreme heat there. The East and Midwest has been in a downward moving ridge. April, snow every day in Minnesota. Snow on the ground every day, and it's snowed every few days here in April, the entire month, right? The rainfall and the flooding we see now is because of that, okay? So when the gradient drops, the jet stream gets curvy, and when it gets about 7 curves in it, it stabilizes and sits there and doesn't move. The jet stream is moving, but the curves aren't moving, which causes you to get long periods of extensive rain, long periods of drought. That's just one example of the outcome of that change. Hurricane Sandy was actually part of that. But because the Arctic changed, Hurricane Sandy did something hurricanes almost never do. Most Atlantic hurricanes that don't die in the Gulf go up the Atlantic and disappear in some place we don't even know where it is, like Pittsburgh or someplace. There's a bunch of rain up there. Okay, but Hurricane Sandy got near New York, turned left, and smashed. It stopped being a hurricane just before it hit New York, not because it weakened, but because it strengthened. And hurricanes are defined by their shape, their morphology, as well as their strength. And Hurricane Sandy gained strength and got all weird and stopped being a normal-looking hurricane. So they turned it. They said, this is now a tropical storm. It's stronger than the hurricane that it came out of. And that's when it hit New Jersey and New York. Okay, and it hit it with a sea level rise over the last century of an additional flood, which made it worse. So sea level rise and changes in weather that we're seeing now are examples of that carbon being released, that dinosaur carbon and so on being released in the atmosphere at rates that the most volcanic activity we can imagine, any other natural source, couldn't even come close to an order of magnitude or two less than the largest we've ever seen. This is a remarkable amount.
I encourage people to look at two pieces of evidence, very extensive pieces of evidence. The first collected from thermometer measurements, so not computer models, but thermometer measurements from all over the world. And though it's possible to pick, in a time of global warming, which we are in, the globe is getting warmer, it is still possible to cherry pick individual locations that are getting cooler. And so we need to step back and take a larger view of the climate, which is about what is happening on the globe as a whole. And one way to look at that is to look at the global average temperature for each month. And if you go back 340 consecutive months from this month, the global average temperature has been warmer than the 20th century average every single month for 340 months. So do a quick computation. For those of you listening, those of you in this room, or those of you who love very much someone who's younger than 29 years of age, they've been living with global warming their entire lives. So please don't tell them that this isn't a problem that we have the responsibility to do something about. Secondly, and the really good piece of news, is that one of the ramifications of climate change is that when you trap more outgoing heat in the atmosphere, which is exactly what carbon dioxide and the other greenhouse gases do, you supercharge the atmosphere. You have more energy and heat in the system. And so the hydrologic cycle is enhanced. And what that leads to very directly is what climatologists at the National Center for Atmospheric Research in Colorado have said is a loading of the dice. That now, every time we look at weather, there is an increased probability that the greater amount of energy in the atmosphere, in the lower atmosphere, is driving more extreme weather. And as the hydrologic system gets enhanced, in various parts of the globe at the same time, we have extreme heat waves, droughts, floods moving forward. And I know in my own state, we've seen those things happening in the same month in the same small state. And climatologists call that extreme weather. I call it expensive weather. And it is expensive because we are now paying for it. And President Obama brought this up. We are now paying the cost, some of the costs of climate change. We're not paying them on our power bills. We're not paying them at the gas pump. But we are paying them in healthcare costs. And we are paying them in insurance rates. And we are paying them in disaster relief, which taxpayers pay for. And so those are the very tangible backyard kind of things and pocketbook issues that are getting more and more attention here in the U.S.
Just to piggyback on what Jay said, that's where it really becomes a policy issue, where the rubber hits the road, is money, right? And with insurance rates, the insurance industry is kind of squaring up to battle certain members of the energy industry on this point, because there's increasing exposure. There's a company called Munich Re that is a major reinsurer of U.S. property and casualty companies, and they track something and published a report twice a year called the Natural Catastrophe Update. And they chart the categories of loss, and on this chart it's always a 30-year look-back window. And all the normal categories that have nothing to do with weather or climate have stayed pretty much constant over that time. But categories of loss that have to do with climate change, meaning hydrological loss, mass movement of water, hurricanes, tornadoes, and wildfires, those have gone up by 4 times in the last 30 years. So it's having a major impact financially on the insurance industry and on our insurance rates, particularly in coastal regions. A lot of coastal regions are really bearing a lot of the brunt of this, although it is spreading into, for instance, the plain states in times of drought. But coastal regions, in some places, you can't get insurance anymore. So who's left to provide insurance? The taxpayer. Local governments are stepping up to the plate in places in Florida and footing the bill for insurance that property owners can't get any other way. So ultimately, we're faced with paying for this one way or the other, and that's where it becomes a policy issue that has traction in Congress. And that's one of the reasons that President Obama is really working to get Americans talking about it, which is refreshing.
Okay, so we have a lot of evidence, but how are we communicating that evidence to people? And it seems to be that there's almost two separate audiences. There's policymakers and then there's private citizens. So how are we doing with that? And maybe we'll go back this way.
Pretty lousy,
Good.
by and large, for a number of reasons. First of all, scientists, by and large, are not very good communicators, except in the way that they communicate their research results. But there is a very strict order that they've been trained to follow, and that order is not particularly convincing or helpful to lay audiences. Also, scientists, since, for the last 50 years, really have kind of stepped out of the national conversation since the NSF started funding research, and they didn't have to go to private funders for their research. So the muscle to communicate about their work kind of atrophied, and an attitude developed that that engaging in communication really was something that you did after you failed at your science. In fact, in a lot of universities, there's a strong disincentive in tenure programs for professors to engage in public outreach. That's something that I've been working to convince people to change. But with scientists out of the action, the people that have really been talking about it are the people with vested interests, people who have a lot of money that want to convince policymakers and the public of a certain point of view to protect their investments. And that's understandable, but it's led to kind of a off-kilter discussion in the United States. And those of us who have thought that science had enough authority to carry the day were sadly mistaken. And we are playing catch-up at this point. And we're making some good progress. We're getting a lot more sophisticated, especially over the last 2 or 3 years. But we're still, I would say, we're still quite a bit behind. Hopefully the Obama speech will be the beginning of a turning point, but he does have somewhat of a record of making major speeches that then really are not followed up on with action. I hope that's not going to be the case here.
Fortunately, we don't have to rely just on scientists for communicating this problem. This is a problem for all of society, and the solutions to this problem are going to be the kind of economic and job and creative transformations that a lot of us are working for anyway, and that will give us the kind of quality of life and the kind of resilient culture that will move us beyond the older technologies to new technologies that are in some cases sexy, often very exciting, something that people are very much attracted to. And how do we get those into the marketplace at the right price point as soon as possible?
Can I give you one example?
How do we scale up? Please do.
Tesla. That is the coolest freaking car company ever. Total electric car, 0 to 60 in 4.2 seconds, faster than a Porsche.
Yeah,
And it goes 260 miles on a charge. It's unbelievable.
So there is a real pull to those types of technologies. And the number one reason for that is not climate change or concern about global warming, but those are the types of technologies that will absolutely help mitigate or slow down this problem. And I think one of the big mistakes that has been made in the past on communications about climate change is that it's just about trying to get pretty much a scientifically illiterate America to deeply understand climatology. And that should not be the goal. In fact, I was at, a couple of years ago, a AAAS meeting where this was a piece of data I didn't know, that 75% of people in the United States do not know a scientist in their daily lives. And so it's not like they're going to get regular communications from scientists. Now, nonetheless, scientists, climate scientists who publish on this issue are very credible messengers. And so we have to encourage those people who are willing to do this and are good at it to speak up much more loudly and much more clearly. So clearly that needs to happen. But the thing that I pulled away from President Obama's announcement, looking at the reactions to it, for me the most interesting one was a set of messengers that I have found to be very credible with every American I've ever worked with, and that is the healthcare community. And take a look at the American Lung Association's website and what they say about President Obama's action with regard to coal-burning power plants. And you will see the American Lung Association stating coal-burning power plants kill people. And that we have a set of actions going forward and we need to take those responsible actions. And that we have, as I mentioned before, through the Clean Air Act, we now have a 43-year, very methodical, step-by-step process where when health science tells us that there is damage being done to human health and welfare, it is the job of the federal government to set limits on that pollutant and cause it to go down over time. And we have had great success in that with lead pollution, arsenic pollution. We just started on mercury pollution, way late, but we just started on that. But we're getting 90% reductions in mercury pollution for burning coal in Minnesota and other places. And now it's the time for carbon pollution going forward. So I think it's interesting to think about where it is, where people are really at. And they're not wondering, what does a climate scientist say? But they're wondering, what is happening with this extreme weather? Is there anything we can do about it? And I think the other critical thing that's often missing from our communications on this topic is that there are dozens of things that are now being done about the problem, that if scaled up very considerably and very fast, will help us get control of this problem. And so I always try to communicate by talking about what we are doing on energy efficiency and renewable energy and how that is cutting carbon pollution emissions. So growing the types of clean energy that save customers money and provide jobs for their families, family-supporting jobs, that are going to be resilient for a long time to come, and are going to be solar panels and devices made in the Midwest and made and installed here in the Midwest, are things that many people are attracted to. So don't just think of Tesla as a one-off. Think about what is the Tesla equivalent that's going to be at the right price point, so which is very important, for everything we do that uses energy. And think about whether you know people who are now being trained in engineering and sciences and marketing who can bring those things to fruition much faster. So I think the really great thing about this challenge for us is that people with almost any kind of background can apply part of it to helping solve this problem, and that we can all work together and get it done. It's the can-do spirit that we need to tap into here.
Yeah, that's all. I agree with all that. I think that Shawn suggested that scientists are bad communicators. And I know some of you have been following certain other debates as well, and people who read P.Z. Meyer's blog and my blog. Some of you may have been at the great slapdown at the Bell Museum a couple of years ago, which we argued about whether scientists are good communicators and so on. And there's an argument that scientists are actually very good communicators. And the argument is, Carl Sagan and Neil deGrasse Tyson. You can point out individuals who are great communicators. And I think that the proof that scientists are great communicators is to look at how many scientists study evolutionary biology and how well they have done at convincing the population to not be creation. That didn't work, actually, did it? Now, it turns out that over the last several decades of considerable effort by some of us, the public opinion on evolution versus creationism hasn't moved an inch. It hasn't moved an inch since Clarence Darrow's time. Okay, it hasn't moved. And as a matter of fact, climate science, the public view on climate change has moved more. It has moved tens of percentage points, sort of back and forth, but at least it's moved. Okay, so there is, but it's still not good. It's still the case that virtually 100% of scientists who study climate change have the same pretty much perspective on climate change as reality and the nature of it and the causes of it. And the literature is pretty much close to 100% on this as well. And with regular people, it's way closer to half and half. The media still believes that they have to, much of the media still believes that they have to give two sides of the story. One side is utter bullshit, and the other side is what's real. And and I think that's the state we're at now. And one of the things that people are doing, what I'm sort of observing, I can't measure this, but what I think is happening is a lot of people who have been, like 5 years ago, were saying climate change isn't real, and if it is, it's not important, and if it is, it wasn't humans, and so on. there's kind of a scale of denialism. It isn't real, humans aren't causing it, to, okay, it's real, but it's not important, humans aren't causing it. Okay, it's real and humans are causing it, but it's not important. And that is a new form. And this is what you're seeing more and more, a larger and larger percentage of climate change denialists now will say, it's real, it's important, and humans are causing it, but we'll adapt. And there's even a newer version of that I'm hearing more and more now, which is it's real, it's important, humans are causing it, and we'll adapt, and that will be fun. Because we're going to get to do things like move all of the cities from the coast and build new ones. And I agree that in the worst possible case, we do nothing about climate change at all, nothing whatsoever. Okay? I decided I was going to write some fiction about the future if we didn't do anything about climate change. I started like running numbers and asking my climate science expert friends about this. Like, what is the really worst case scenario? Given 500 years, okay? Given 500 years of doing absolutely nothing but burning coal for making energy, what's the worst case scenario? And it turns out it's pretty darn good, okay? Because right now we have 7 billion people and a lot of problems. And about 500 years ago, according to some of my own numbers I ran, we'd only have 100 billion people, and we'd be living in small villages, and we'd be very happy. We would have technology, we'd be growing our own food, and it'd be warm. And the United States would be about a third off of its present size, and so on. So I guess my point is that I agree that scientists are not good at communicating, and the response to this effort right now, and this is what you're seeing among your friends and family and relatives, is that adaptation's okay. And doing nothing about it is still okay, because adaptation will actually be okay and will actually be fun. And that's, to me, maybe the worst outcome.
Well, Fresh Energy's done a lot of work over the last few years in actually working with scientists, university scientists, government scientists who understand the basic atmospheric physics and chemistry, and are often asked in the media whether climate change is real. And we always encourage them, as they're talking, and they want to talk about their research. They want to talk about cutting-edge research, which is a different question. And so members of the public who are listening to those media do never hear what scientists know for sure, which is that carbon dioxide is a greenhouse gas that always traps heat in the atmosphere and always warms the earth. And so that very basic level of information never gets across. So when I'm talking to scientists about communication, and many of them I've worked with can be very good on this issue, but I always say, although you want to talk about your cutting edge research more than anything else, remember, this is what maybe the only chance this year that people in your audience will have to hear about science from the scientists, and make sure that you tell them what you've known for the last 30 years, that you know for sure. And make sure that that gets across 3 times in your presentation, because it might be the only opportunity. But I want to talk about the first law of holes. The first law of holes is when you find that you're in one and you want to get out of that hole, you have to stop digging. The United States at the federal level, at the state level we're starting to get this, but at the federal level hasn't really gotten that message yet. And they need to hear a clamoring from the public that we are in a hole, that carbon pollution is damaging our health and our infrastructure, and it's going to be very expensive for us and our kids. And we need to put a lid on that for the first time ever. We need to put a limit on carbon pollution where there is none. And so what President Obama is trying to do is to address that first law of holes, and starting with, appropriately, the biggest source of carbon pollution, which is coal-burning power plants. But really, he didn't start there. 4 or 5 years ago, actually a little bit more than that, the big 3 auto manufacturers came to Congress and said, we are about to go out of business. American will no longer be a car-producing, not to mention Tesla, but no car-producing. No car production will happen. And the president and some members of Congress got together and they determined that there would be a bailout, a limited bailout of the auto industry, but that it really didn't make sense to bail out an auto industry so that 10 years from now and 20 years from now, they're still going to be making shitty cars when it comes to fuel efficiency. That really we need them to get better and better cars going forward. And so part of the deal that was struck with auto executives going forward is that by the year 2025 in this country, across all light cars and trucks, the average fuel economy will be increased to 54.5 miles per gallon, roughly doubling. So here's what to think about when you're thinking about, is this doing anything about the climate change problem that's positive? Every time you cut waste and increase efficiency, you are reducing carbon pollution. So that was the #1 thing that this administration has done for carbon pollution. The second thing they did was a couple of years ago, they proposed limits on the amount of mercury that can come out of these coal-burning power plants. And there was an outcry in Congress, people in Congress who were funded by big oil and big coal lobbyists, primarily, were being told that we're saying in floor speeches on the U.S. Senate that this would put state X or state Y out of business. That there's no way you could run an economy and cut mercury emissions by 90%. And I'm very happy to say that our senior U.S. Senator, Amy Klobuchar from Minnesota, got up on the floor of the U.S. Senate about a year and a half ago, and she spoke to Minnesota Experience, where working with energy groups like Fresh Energy and the Chamber of Commerce and big utility companies, we passed a law that voluntarily calls for 6 of our biggest coal-burning power plants to cut mercury emissions by 90%. And they are doing that ahead of schedule. And so Amy Klobuchar got up on the floor of the United States Senate and said, please don't tell me this can't be done. We are doing it at an incredibly low cost in Minnesota. We need the rest of you to do it too, because some of your air blows into our lakes and fishing ponds in Minnesota. And now that is the law of the land. So this is step 3, to go back to that #1 source of power plants. And I just want to give you a sense of this scale. The biggest coal-burning power plant that supplies my electricity burns 3 train loads of coal a day.
Is that Monticello?
It's at Sherco. It's called Sherco. It's the Sherburne County 123 plant. 3 train loads of coal a day. So as you're thinking about what are the new technologies we need, we also need to clear a path for those new technologies to provide our energy, and we need to systematically get rid of the 19th century technologies, which is burning coal to produce electricity. We need to get them to clean up their act, stop polluting for free, take the advice of economists, internalize those externalities, and move forward. So this is an important step, but as Shawn mentioned, the president has a mixed track record, great speeches versus actual actions. And he is going to need, and his administration will need, a very strong concerted push from Americans moving forward in every state to say, yes, we need to get this done going forward, and we need to grow the clean energy economy alongside of it.
So what else are we seeing in terms of policy?
Well, when we talk about policy, I want to talk about the mix of policymakers and media a little bit, because from my perspective, that's a really big part of the problem. Is that for instance, Congress, 535 elected representatives and senators. How many of you guys suppose have a professional background in science?
30? 30?
6. There are 2 physicists, a microbiologist, and 3 engineers. How many do you suppose are lawyers?
The rest.
226. So it's little wonder that we see more rhetoric-based argumentation than fact-based argumentation going on up there. And a lot of those lawyers came up through the humanities because what did they try and get away from in college? Science class. All right, so then think about who's reporting in the media. A bunch of English majors. What did they try to get away from in college? Science. So when you think about that, it's interesting. When we first started organizing science debate, I talked to a bunch of AP reporters, news directors, editors, because they kept saying it's a niche topic. All these candidates, campaign managers were telling us it was a niche topic, that people just weren't interested. Who's interested in science? It's dry, it's dull, it's boring. So we decided to test that. And we did a national poll, and we found out that 85% of Americans think they should be talking about this stuff. It's just the people in the media, largely, who aren't interested in it and think that everybody else is, and it's confirmation bias. So one thing that you guys can do is start asking the media to report on that a little bit more. Start pressuring them, letting them know that we do care about this, and we do care about good reporting. Because what happens then is the other thing that journalists are taught is there's no such thing as objectivity. And you see that everywhere if you start looking for that. You can Google journalism, no such thing as objectivity, and all kinds of journalists say that. They're taught it in journalism school, have been for the last 20 years. And that may be true if you're covering political issues, or if you're covering issues that have to do with he said, she said, and you're doing a human interest story or something like that. But when there's a big science component, like there is in climate change and like there is in lots and lots of the big policy issues that we're stuck on now, there is such a thing as objectivity. That's what science is all about, is to try and build knowledge that goes beyond our individual gender identities, our individual emotional senses of things, our individual faiths, our individual racial background. All of those things are separated out, and we wind up with knowledge, and that is objective. And the idea of democracy is to find knowledge and to base the best public policy on that. So journalists are cutting the cord and setting us, well, that's a mixed metaphor. So a journalist will probably hammer me on that one, but they're cutting the cord and setting us adrift. Because we can't make a wise decision as a people if we don't have the knowledge that we need. So that's a big, big, big component. And I'll give you a really simple example of how it works. In journalism, there's always two sides to every story, right? So Bob says 2 + 2 = 4, and Sally says no, it's not. 2 + 2 is 6. The controversy rages. They write up a story on it. They sell newspapers. People get outraged. That's Sally. She's nuts. No, I think that she has a point. Right? Then you ask a scientist, and they'll say most times one side is simply wrong. I can show you with these apples that Bob is clearly right. 2 + 2 = 4. But the newspaper isn't reporting it that way. So you wind up with policymakers. You say, how about a compromise? And we get a new law that says 2 + 2 = 5. That's America in a nutshell on climate right now.
I want to talk about how you can help us amplify the voices of your own voices and people like you. And I want you to know that there are lots of people who want much more wind energy, solar energy, all kinds of renewable energy, and hate the fact that we are an energy inefficient economy here in the United States compared to Europe or Japan, and want that to change. And here's an example of that. And we need to get these voices into the media and to policymakers. And I'm sure this is true. I live in one small state, but I'm sure this is true whatever your state or province is. If you do bipartisan polling of people and ask them, where should our next source of electricity come from? And give them an open-ended slate or list the various sources of electrical energy, less than 25% of them will say that it should come from burning new coal. And 75% of them in every district, this is true in Minnesota, I'm sure this is true in your part of the country or the continent as well, will say it should come from solar or wind energy. In fact, in Minnesota, when this poll was done less than a year ago, in January of 2013, in every region in Minnesota, Republican and Democrat, 90% of people favor wind energy and solar energy going forward. And when we took those bipartisan polling numbers to Minnesota legislators this year and urged them to build on Minnesota's renewable electricity standard, which calls for getting 25% of our electricity from renewable energy by 2025, and every utility, thank you very much utilities, are meeting this ahead of schedule, and said, let's build on the success and create a solar energy standard in Minnesota. The Minnesota legislature did that. And so in the next 6 years, because we have a solar energy standard, the amount of solar energy in Bloomington, Minnesota, where we're sitting now, and all parts of Minnesota will increase by 30-fold. And so we will start to see these technologies, large and small, in our communities, and that will get many more conversations going about how to make sure that we get solar energy for all people in all communities going forward.
All right, and I know we have some questions, so why don't we start at the back? Or, sorry, yes.
Me? I'm very glad to hear you say this. My brother, who has been in touch with utility companies, continues to send emails out to our family saying, renewables are wonderful. What about the baseload power? What do we do about energy storage? Is this being addressed? Currently you need fossil fuels for.
I would love to talk about this. The question is that often you hear back from utility companies that are running some of these coal-burning power plants that people need baseload sources of power that run 24/7 in order to keep the lights on. There is no need for a power plant running constantly because we're in a system that in most parts of the country is linked to multiple states and hundreds of different generating units that can be pulled through transmission lines. The beauty of a transmission grid. There is a baseload demand for electricity, that people need certain amounts of power, hopefully decreasing over time as we get more efficient, to heat and cool their homes and run their businesses and power life. And what we're finding is that through a very robust transmission grid that links together diverse generation sources that run through what is called economic dispatch. So for instance, if you have a wind farm that produces electricity, or a big solar array that produces solar electricity, when the sun is shining or the wind is blowing, which it is almost universally somewhere in the world at some point in time, and you link enough of these places together, but that's the fuel that's free. And so that's the first power that you should put on the transmission system, and that is how electric utilities function going forward. So we're finding that the concept of baseload power is just antiquated, that instead it has been replaced by a robust transmission grid that allows the very well-versed system operators to pull from their system the most economical source of power when they need it going forward. And we are starting to diversify our electricity system as a result of that going forward. So it's an old notion that you need one power plant to fuel the city of Minneapolis, for example. In fact, we are running our cities and our towns and our businesses on a broad array of power that is getting, and the grid is getting smarter and smarter over time.
Also, the effects of climate change themselves have an effect on the base load, a significant one. We had the largest power outage the state has encountered a couple weeks ago with that big storm. Climate change effects actually cause perturbations in the grid that are significant. And also the base load effects, people often bring up nuclear as a base load because nuclear just sits there and never breaks and always works and does the same amount of electricity every single day. But actually what happens is it doesn't, because plants have to be shut down for refueling. When a tornado warning shows up at the Monticello power plant, they turn that plant down, for example. So there are, in other words, the base load. Another thing just to mention is in a more sophisticated version of the future, if we have something like a smart grid, where we have battery storage in everyone's home because your car is running on electricity and you have it plugged in and so on. This is where adaptation is fun. We can get a better power grid by having cooler toys to some extent as well.
You know, I think the best evidence is from power companies who are voluntarily making the economic decision to move away from coal. And my favorite example is about an hour and a half south of here is Rochester, Minnesota, home of the Mayo Clinic. There is a coal-burning power plant that's the oldest power plant in Minnesota, and the operators of that plant 10 months ago announced that they had received their last delivery of coal, that for economic reasons they were finding it cheaper to go out onto the market and buy wind from western Minnesota and natural gas-fired electricity and to invest more in efficiency. And that was much cheaper than relying on coal, which in the Midwest is going up in price about 11% per year. Much cheaper to do that. And they added, remember what I talked about health messaging before? They provide power to the Mayo Clinic. The power plants I'm talking about are clearly visible from the Mayo Clinic. And the people who operate that power plant said, in our health-conscious town, we couldn't rightly continue in 2013 burning coal to produce electricity.
The individual with the books on their head.
I was wondering, I heard this somewhere, I don't remember where, but is Minnesota or the Midwest in general ground zero for climatic change, extreme weather and stuff? I heard that. Is that true?
You know, I've heard that as well, and the thing is, that's probably not a very good characterization, because the outcome of climate change to me, the biggest long-term effect of completely we do absolutely nothing, let things just run. The biggest effects are probably actually going to be sea level rise, because if sea level rises several feet, displaces double-digit percentages of our population. Something I've been trying to work the numbers out, but some double-digit percentage of all of the rice exported from countries that export rice in the world would be wiped out with a 5 or 6 foot sea level rise, for example. It's enormously impactful on both human populations and production of food, and that's not an effect for us. So one would argue that the coastlines are ground zero for climate change. So it really just depends on which climate change thing you think is going to be the worst.
What do you
scenario.
think it was? So do you think they're referring to?
Oh, this is what I think they're referring to. First of all, Minnesota is the #3 state in the United States in terms of global warming. We've warmed faster than 47 other states. And for anyone who's grown up in Minnesota, we know that we have an extreme climate because we're near the center of a big continent, away from the ameliorating influences of an ocean. So we have deeply cold winters typically and hot, humid summers. We have a lot of variation, and all of the climate models show that places like Minnesota and north of Minnesota into Canada will see worse than average global warming. We'll see more of it, and that has been borne out in the future. And the other reason I think that you're hearing about it is that Minnesota is a state, just because of its geographic position, that's on the edge of 3 biomes. So prairie biome, mixed hardwood forests, and boreal forests. And so any little shift in temperature ranges, which we are seeing, and we're seeing big shifts in temperature ranges, means that the habitat for those ecosystems will move, in some cases, out of the state of Minnesota. I think it's actually not bad to think of it in terms of what's happening in your backyard, because that's how most people live day to day. And to think about, but you really need to think in terms of climate. So you want to think in terms, rather than weather outside your window right now, is to think about what are the species of trees in the forest where your cabin is that you've been going to as a family for 50 years, and how is that changing over time? So you want to think long term.
The person in the hat. The user.
Among the community that accepts the reality of global warming, there is an information conflict, and I find that I'm too far removed from the source data to evaluate this conflict that I've read about. I've seen excerpts, like I said, several stages removed from the fact that I've seen excerpts of United Nations reports, specifically from the World Health Organization, that say that over half, that the effects of meat production, large numbers of people eating more meat than ever, the meat being grown from crops which are based on non-renewable resources, in other words, all the fertilizer is coming from oil and coal, that the effects of that is greater, considerably greater than the effects of all electricity and all transportation put together. And I don't know how to evaluate that. I do understand that methane is a much more potent greenhouse gas than carbon dioxide, but this claim that it's over half, that I've read a few times now, is intriguing to me, but I don't know what to make of it.
Yeah, I think when you're talking about a problem where the scientific advice is we need to essentially decarbonize the economy, we need to figure out how to plan for that over the next several decades, and certainly by the year 2050 we need to get to at least an 80% reduction in carbon pollution, which is the goal of the official goal of the state of Minnesota, by the way, and several other states as well. You need to have a really good handle on where the carbon pollution is coming from. The role of agriculture and production of our food is going to vary quite considerably from one country to another, depending on whether you're the U.S. or Japan or Senegal. And so the variation is really quite great. In Minnesota, the contribution is about 14% of the carbon comes from agricultural sources. So it is an important source, but it is by no means the top source. Fossil fuels
But
are
how
much
important
more
is methane? That's my question.
Methane is very important because methane is a very powerful greenhouse gas, but it also has a shorter lifespan in the atmosphere than carbon dioxide. And so we need to address methane as well, and the President spoke to that as well. We need to look at all of the greenhouse gases going forward, yes.
Part of the issue with animal agriculture that may be referring to is that in some countries For instance, rainforests are being cut down in order to increase grazing space, grazing land. So you're having you're having a double effect. Trees pull carbon out of the atmosphere by eliminating them and turning it into grazing land. You're attacking, or you're making the problem worse from both angles. Cows, of course, do constantly emit methane, and that's part of it. Methane is, in a 20-year window, about 20 times as potent as carbon dioxide as a greenhouse gas. But also, you think about all the other things that go into that meat production, all the grain that is eaten, and all the transportation that goes on. Ultimately, it's about 70 times the energy used to get a calorie out of a cow to eat in beef than is eating a vegetarian diet. So that's probably part of what you're hearing, but generally speaking, as Jay said, it's hard to say that it's more than half.
It's important to distinguish between carbon or methane that is trapped in fossil sources, and the methane that the cows release is just fine.
That's part of the short
cycle. It's actually
cycle. Part
of the short cycle is they're eating grass and turning it into methane, and we could burn grass and burn trees, same thing for carbon. It's when you take coal and oil and methane and permafrost and release it, you're changing the budget, in a sense. You're changing the balance. But having said that, agriculture is usually important globally. Most of the energy that you folks in this room, most of the carbon you're releasing probably has to do with stuff that has to do with buildings, what we're in now. The one you live in, the one you work in, is as far as electricity and in terms of coal burning and oil burning, your car is after your house and your place of work. But in the meantime, we're all eating, and American diets are actually the most carbon expensive diets of any in the world. If all the people who eat meat every day or a few times a day just started eating it a few times a week, and all the people that are almost vegetarians just became vegan, a few shifts like that, we would get more in line with the rest of the world, and that those sort of thresholds of carbon amounts and methane amounts would be reached much later, many years later.
And one of the reasons, one of our challenges for really behaving better as Americans and more responsibly, not just in our diet for our own personal benefit, but also for clean energy, and why I've been focused on that so strongly this hour is we're facing a world that in a few decades is likely to have 9 billion people. Many of whom do not have electricity now, do not have access to the things that I have enjoyed my entire life, like vaccines that are refrigerated, and air conditioning, and automobiles, and animal protein. And most of those people will want more and more of those things. And so our challenge is not to deny them, not to go into a bunker mentality, but to figure out how will all of the world be able to have those benefits of properly maintained food and medicines, and access to light and heat and cooling in a way that is much more, much lower in carbon going forward. And how do we get there sooner rather than later?
And those of us who have worked or lived in so-called third world countries over the last few decades, you notice, we have a cell phone system in this country, and for several years the cell phone system expanded and grew and always sucked. But you go to a country that gets cell phones in 1997. By 1998, their system is 10 times better than ours because they didn't have anything before, and they've implemented the best technology available. Japan, post-World War II, became an industrialized country that was far better than the way it industrialized in the United States had been in Britain, and we were the ones that invented industrialization. So in a way, it's not like everyone has to go through the 19th century and the early 20th century and take 150 years to get to the point where they make a windmill. That's not how it has to happen. They can start with the windmill and move on from there.
No, we actually are completely out of time, but I'm looking for something insightful from Shawn to sign up with.
Okay, well, the cool thing is that the problem is solvable, and that we have the ingenuity to do it, and it's creative people like those of you in this room that are the ones that are going to do it. By figuring out new ways to inspire people, new gadgets to get behind or to invent, and new ways to put pressure on our elected representatives to get off their dupps and solve the problem.
Look at it this way.
Put your creativity to work and get out there.
We are the healthiest, wealthiest, best educated, best connected generation in human history. We have to do great things. Of course we have the capacity to do them. Thank you.